Hey math kids, let's just get started with this. So we need to show that line 1 is, and line 1 and line 2 are parallel, but not coincident. So it means they have the same slope, but they are not the same line. And so that's exactly what we'll do. We write down the direction vector, which is just this part. So 2, negative 2, 4. Direction vector over here, negative 1, 1, negative 2. Now, if we just multiply this by a negative 2, like all the pieces, we're going to get 2, negative 2, 4, and since this is the same thing as this, we know that they are parallel. They have the same slope. But we also need to check to see if they cross each other. So what I'm going to do is plug in a 0 for s, which crosses these out essentially, and we get this point. Now, we want to solve for t, which in this case is pretty easy right there, because if we plug in 1 for y, we see that t is equal to 1 as well. So we're fixing that to that, and we found that t is equal to 1. So if they are coincident, these should all be the same. So if we plug in a 1 here, we get negative 2. 3 minus 2 is 1, so those are the same. And if we plug in a 1 here, we get a 0. Since these are not the same, they are not coincident. We prove parallel and not coincident. Okay, the next part, we need to, let's see, line 2 and line 3 intersect, and then find angle. Okay, so eventually we're going to use this thing. But first we need to prove that they intersect. So what I'm going to do is set these equal to each other. So 1 minus t equals 1 plus 2u. T equals negative 1 minus u. And then 3 minus 2t equals 4 plus 3u. Okay, solve for t over here. Solve for t over here. It's already done. Set these equal to each other. Okay. And then plug in the 1 here, and t equals negative 2. Alright, we have these two values. We want to just check with the one that we didn't use. Minus 2 times negative 2 equals 4 plus 3 times 1. That's going to be 3 plus 4 equals 4 plus 3, or 7 equals 7. So that checks out. Okay, so that's a true intersection. And then we just need to find the direction vector. So we'll kind of look right here. So for line 2, we get negative 1, 1, negative 2. And then we're going to dot the direction vector over here, 2, negative 1, 3. So remember, we multiply like terms and then add them together. So negative 2 plus negative 1 plus negative 6. And so that's 6, 7, 8, 9. So that's negative 9. Plug it into the top up there. It's absolute value, so it's positive 9. Now we need to find the magnitudes of each of these. So let's get a little more room. So we have negative 1 squared plus 1 squared plus negative 2 squared, square rooted. Then this one would be 2 squared plus negative 1 squared plus 3 squared, square rooted. 1 plus 1 plus 4, 4, 5, 6. So we have square root is 6. And then we have 4 plus 1 plus 9. And that's 14. And then if we multiply those together, we get 9 over the square root of 84. And this is equal to cosine theta. So if we do the inverse cosine of both sides, we get this. Come to our calculator. I'm going to make sure I'm in degrees, which I am. Then we do the inverse cosine of 9 divided by the square root of 84 we end up with 10.9. So that's the angle between those. And then we just have a part C that we need to do. Okay. Part C, they want us to show that line 1 and line 3 are skew. So what skew means is it's not parallel and it doesn't intersect. So like on a two-dimensional plane it would look like this, but imagine that this line is like raised out of the page and it's not touching them. So that's what skew means. And so we have to prove two things: not parallel and not intersecting. And so let's prove the not parallel first. So if I take the direction vector of 1, and I take the direction vector of 3, since this is a 2 and this is a 2, there's nothing we can multiply both of these by. The way you kind of show it is this. It does not equal k times some value. So they're not parallel. Now we just need to show that they don't intersect. And so we're going to kind of set that up the same way we did the previous one. So negative 1 plus 2s equals 1 plus 2u. I'm just setting y's and x's together, or equal to each other. Okay, so I'll solve this one for s. Add 1, 2s equals 2 plus 2u. Divide by 2, so s is equal to 1 plus u. Do the same thing here. Now if I distribute the negative, it gives me 2 minus u over 2. Set these equal to each other. 1 plus u equals 2 minus u over 2. Multiply both sides by u, or by 2. 2 plus 2u equals 2 minus u. Add u to both sides. 2 plus 3u equals 2. Subtract 2. 3u equals 0, which means u equals 0. And then if we plug that in here, we can see that s is equal to 1. Okay, we test it over here. And so we get 1 plus 4 times 1 equals 4 plus 3 times 0. And 1 plus 4 equals 4, 5 equals 4, which is obviously false, so this is not a universal solution, so that proves that they don't intersect. And that's the two criteria for skew, and so we know those are skew.